Hello everyone, Noah Housley again with dynamics, and we're doing an example problem just from the book in chapter 11, I think after chapter 11.4, working with curvilinear motion. And this problem we're doing a projectile problem. There's a ski jumper going off of a cliff on an incline, and he's going to land on the incline, and the incline's at 30 degrees. What they're looking for in this problem is they're looking for time, length of the jump, and the max vertical distance. Okay, so time from when he lifts off to when he lands, the length, so d of the jump. So notice that's a inclined length. And then the max vertical distance, so the max point that he will be at in between the ground and the air. Notice how that's different at certain points on this example projectile path. So this is a projectile problem. The initial velocity and angles are given, as shown. The angle can be tricky, but of treating it like how he lands and things like that. But it's the same as if the ski jumper left at an angle. So hopefully that makes sense. That's like saying instead of looking like that, we can just turn it and the jumper is now going off at an angle. And so these are just the same problem. Okay. So, kind of approach that I wanted to go on this problem. First, we want to solve for the normal projectile and find a vertical distance. Normal meaning just the original projectile. And we want to find distance. Next is we want to find the max vertical distance. And for that one, I think I'm going to treat it more like this. I think that would be easier to conceptualize and understand and solve for. So that shows that I have these equations down here. So first, we know that on the x side, x is equal to velocity times time. And we can solve for time there. For our first thing that we want time. Next thing we know is that y is equal to initial velocity, and in this case, there is no initial velocity in the y direction, so that crosses out. And plus 1/2 at squared, which comes out to a negative 1/2 times 9.81 meters per second squared. And what I did here was I took this and plugged it in for time. So I'm combining the two equations there. So I have x squared over 25. Some extra equations that we want to know about is that sine of theta is equal to y over d. So the sine of this theta is going to be the vertical distance that he lands divided by the length that he goes, which is what we're looking for. And then the same relationship with cosine, just x over d now. In that case, the horizontal distance over the length of the jump. Okay, so I'm going to use these to solve, and I'm going to kind of simultaneously solve for time and length. First, I plug in d sine of 30, which equals y, into there, since I don't know y. And I'm going to have it equal negative 9.81 over 2 times x squared, and x we got to be equal to d cosine of theta, so d cosine 30, and that's squared, and 25 is squared as well. I forgot to square the 25, but since it was x over 25, both are squared there, so it's squared there. And now we solve for d. Work it out. I got t to be 3 seconds and the length of d to be 85 meters. Okay, so that checks off 2 of the things. Now the max vertical distance. Now you could say, hear the word max and think, well, derivative, but I just decided to orient the problem in a different way. And I turned it horizontal. So this is the incline. Now I know the distance that he lands. It's 85 meters that we got. And now all I need to do is just break up the 25 instead of just having it in the x direction. I broke it off into components. So my v in the y direction is 25 sine of 30. So, and I'm looking, so the max is when he's at the top height here. And at that point, he's going to be the furthest away from the ground. And so what I did was I just said at this point, Vy is 0. So I can use, and you can see I tried a couple times different equations here. I can use the Vf squared equals Vi squared plus 2ax, or y in this case. And then solve for y, where at what point is he the furthest away from the ground. And at that, I got 8 meters. So hopefully I did that right. Comment if I did anything wrong. Thanks for watching.